Hello everyone. In this video, we will discuss about a chapter called Electric Charges and Fields. I will divide this chapter into few parts. In this video, we will discuss about charge and its properties and electrification of any object. So, how we'll define charge? Charge is the property of matter that causes both electric and magnetic effects. Charge, property of matter that causes both electric and magnetic effects. And generally, we will represent charge with the letter Q. It is a scalar quantity, and its units are named after a scientist called Coulomb. Will represent with C. And if Coulomb, as it is a large unit, will represent charge are with microcoulombs, nanocoulombs, and picocoulombs. Micro means 10 power of minus 6. Nano means 10 power of minus 9. Pico means 10 power of minus 12. And its corresponding learning dimensional formula for every physical quantity is very important. So, ampere into time. And we are having some fundamental particles called electron as well as proton. For electron, one electron charge is 1.6 into minus 1.6 into 10 to the power of minus 19 coulombs, and proton charge is plus 1.6 into 10 to the power of minus 19 coulombs, and neutron, it is electrically neutral body, so that its charge will be 0, and mass of electron is 9.11 into 10 to the power of minus 31 kg, and mass of proton is 1.67 into 10 to the power of minus 27 kg, and mass of neutron, as per nuclear physics, it is slightly greater, but for our numerical calculations we'll take closely to mass of proton 27 kg. Why we are discussing mass also here means because they will ask you one term called a specific charge. Specific charge. Specific charge is nothing but charge to mass ratio. Charge to mass ratio. Suppose they may ask you like this: specific charge of which particle is greater, electron or proton means. So you can give an answer like this: specific charge of, as both are having same charge, so mass is less for electron. So specific charge of electron is greater than that of the proton. Okay, because mass of proton is greater than mass of electron. So specific charge of electron will be greater than that of proton. This kind of questions you can expect. And in any object will have atoms, and atoms inside the nucleus will have protons, and outside the nucleus electrons revolve around the nucleus in various circular orbits. Generally, number of protons will be equal to number of electrons. So if number of electrons is equal to number of protons in any object, that object is said to be electrically neutral. Electrically neutral. So it is having equal number of positive and negative charges. We can say like this, it is having equal number of negative and positive charges. Then we can say that it is electrically neutral. And similarly, for that object, if we are adding electrons, if electrons were added to that object, so that number of electrons will be greater than number of protons, we are increasing negative charge, then that object is said to be negatively charged. It will be a negatively charged object. For a negatively charged object, we'll have excess of electrons. We'll say that it is having excess of electrons. Similarly, we can't add protons because they lie inside the nucleus, and hence we can remove electrons if electrons were removed from an object. If electrons were removed from an object, so number of electrons will be less than number of protons. Then we will say that it is a positively charged object. So it is about not excess of protons as we are removing or adding electrons. We have to learn along with electrons only deficiency of electrons. Deficiency of electrons, that object will acquire positive charge. So we'll have neutral objects means it will have equal number of negative and positive charges. Negatively charged object means it will have excess of electrons. Positively charged object means it will have deficiency of electrons. Okay. And the process of providing charge to an object. If we are providing charge to an object, process of providing charge, we'll call that as electrification. Now we'll learn about electrification. Electrification, process of providing charge to an object is called electrification. Process of providing charge to an object is called as electrification. We are having three different methods. The first method is by friction. So this method is observed only in insulators. observed only in insulators. So what is meant by an insulator means insulator does not allow flow of charges, does not allow flow of charges. We'll call that as insulator. And if insulator is charged, charge will be distributed throughout the volume of the insulator. Charge will be distributed throughout the volume of the insulator. We can call them as non-conducting objects also. An insulator means it is non-conducting because in latter part of this chapter we'll get non-conducting sphere. If it is charged, charge will be distributed throughout its volume. So non-conducting sphere means it is an insulator. So if in this method by friction, we'll come to our actual part of this chapter. So if we are having a glass rod, plastic, plastic rod, and we are having a silk cloth, any cloth like silk cloth, both are insulators. If we rub the plastic rod with this silk cloth, among these two, one will have greater electron affinity and the other one will have less electron affinity. So the one with high electron affinity gains electrons and becomes negatively charged object. The one with low electron affinity loses electrons and becomes positively charged object. And becomes positively charged object. So this is how we'll provide charge for two insulators. We'll just rub one insulator with the other so that the one with high electron affinity gains electrons and the one with the low electron affinity loses electrons. The next method is by conduction. Observe only in conductors. What is meant by a conductor means allow flow of charges and if we provide charge to a conductor, charge will be distributed only on the surface of the conductor. charge will be distributed only on the surface of the conductor. So in this process, what we'll do means, suppose we are having a charged rod. This is a conducting rod, and another conducting sphere is there, but is initially neutral. It is positively charged. And if we brought this rod in contact with this sphere, if we brought this rod in contact with this sphere, charge transfer will take place from the rod to the sphere. As they are two different objects, charge transfer will take place until they attain same potential. Charge transfer takes place until they attain same potential. Charge transfer will take place until they attain same potential, and hence after certain time, if I remove, once they attain same potential, charge transfer will stop, so that this rod will be still positively charged, and the sphere will also acquire some positive charge. Okay, here we are having one interesting point like this. If the two objects are identical, then charge transfer will take place until they attain same amount of charge. If the two objects are identical, then charge transfer takes place until they attain same amount of charge. So, if you are given like this, just I'll have an example based on this, one interesting example. So, we are having two charged spheres. This is sphere A and this is sphere B. Both are having initially same amount of charge, Q and Q. And we are having one uncharged sphere C. C is kept in contact with A. Then what will be final charge on A as well as C means 0, because as it is electrically neutral, 0 plus Q by 2. So that it will be Q by 2. As all the three are, I am assuming, identical spheres. Then C is kept in contact with B. So now charge on B and charge on C will also change. So it will be Q by 2 plus Q by 2. It will be 3Q by 4. So now they'll ask you what is ratio of final charge on A to final charge on B ratio. Final charge on A is q by 2 and final charge on B is 3q by 4, or that will be 2 is to 3. So you can expect some questions like this by giving identical spheres. So after this, we are having our third method of electrification, induction. This is also observed only in conductors. Here we'll use a concept called grounding. If suppose we are having a positively charged object or any positively charged rod is there, if it is brought close to a neutral object, a neutral object will have equal number of electrons and protons. So the electrons are negatively charged, they will get attracted by this positive charge, and hence our positively charged ions will move to the other end. So that positive charge and negative charge will get separated due to this attraction property of unlike charges, and hence we are having a sphere. For this sphere, as one side we are having excess of electrons, at the other side we are having deficiency of electrons. If it is connected to ground, we'll call this as grounding or earthing. In this process, as we hear deficiency of electrons, Earth is a huge reservoir of charges. It will supply electrons so that it becomes a negatively charged sphere. And if suppose we ground on the other side, where excess of electrons is there, so as Earth is a huge reservoir of charges, if it is having excess, it will remove that, and if it is having deficiency, it will add that, so that in this process, the sphere becomes positively charged. So like this, by using a concept called grounding, we can provide either negative charge or positive charge in induction method. And here we are having some interesting point like this. So as the sphere is at a distance, look at this case, negative charges are somewhat closer compared to positive charges, so that this rod will attract this sphere. Rod attracts the sphere before grounding, as negative charge is closer compared to positive charge. Why I just stress this point means we'll have one theory question like this. Repulsion is the sure test for electrification. Why? They'll ask you like this. The reason is this. A charged object can attract its unlike charge or a neutral body. Charged object can attract unlike charge or neutral body, but repulsion is observed only between like charges. So this kind of theory questions also you can expect. And after this, we'll go with properties of charge. The first property is like this. Charge is invariant. What is meant by invariance means whether it is at rest or in motion, charge remains same. You can represent like this, Q naught is equal to Q. But mass is not constant like this. According to Einstein's theory of relativity, mass varies, m naught is not equal to m. So that we will speak about the rest mass and all those concepts. It is not important here, but mass is not constant and hence specific charge is also not constant. This kind of theory questions they may ask. And the next point is charge is additive. That means in a given system, if you are having more number of charges, total charge of the system, as it is a scalar, you can add all those charges. The next point is charge is conserved. Charge is conserved. We are not adding or we are not removing any charge. Just we are transferring charge from one object to another object. We are not creating or we are not destroying. The charge is conserved. And then we are having one simple point like this. If it is a negatively charged object, as we are adding electrons for a negatively charged object, mass increases because we are adding electrons compared to its neutral state. And if you are having a positively charged object, we are removing electrons, positively charged object, so that mass decreases. And the last point, which is very important, where you will have some good number of numericals based on this, charge is quantized. Charge is quantized. So if charge is quantized means we are adding electrons or we are removing electrons so that it is acquiring charge means we can express charge of an object as integral multiple of charge of electron. Positive sign will use if it is acquiring positive charge and negative sign will use if it is acquiring negative charge. You'll have some good numericals based on this. Suppose if you are given like this, just look at these examples. Find number of electrons removed when an object acquires 1 coulomb of charge. Find number of electrons removed if an object acquires 1 coulomb of charge. Means we have to take Q is equal to Ne, or from this N will be equal to Q by E, or this will be Q is 1 by 1.6 into 10 to the power of minus 19, or I can write 1 by 16 into 10 to the power of 20, which is 6.25 into 10 to the power of 18 electrons. So that this many number of electrons I have to remove from an object so that it can acquire a charge of 1 coulomb. And if suppose you are given like this, just look at this next example. Find number of positive or they'll ask you like this, it is not number of positive, amount of positive charge, amount of positive and negative charge in 250 grams of water. 250 grams of water. If they ask it like this, so that we have to first find number of electrons as well as number of protons, they are equal. So how we will find means, we will go for this concept of number of moles, that is mass by molar mass, mass by molar mass into Avogadro number, that gives number of atoms or number of particles. So that mass is how much? It is 250 grams and molar mass is 18 into Avogadro number is 6 into 10 to the power of 23 into 1.6 into 10 to the power of minus 19. If you solve this, we'll get that total amount of positive charge as well as negative charge associated with this. And another interesting question will be there. Just look at this example. If 10 power of 9 electrons per second were removed from an object, then find the time required for that object to acquire 1 coulomb of charge. So, if they asked for what is charge removed per second, then we are removing 10 power of 9 electrons per second into charge is 1.6 into 10 to the power of minus 19. This means amount of charge we are removing per second. As they are asking time, total charge acquired by number of amount of charge removed per second. Total charge acquired is 1 coulomb by 10 power of 9 into 1.6 into 10 to the power of minus 19, or it will be around, as already we solved this will be 1.6 into 1 by 1.6 into 10 to the power of minus 10 or 6.25 into 10 to the power of 9 seconds, and in 1 year we'll have pi into 10 to the power of 7 seconds. Just count this, you'll get later 365 days into 24 hours. Each hour we are having 3600 seconds. So that if you solve that, you'll get this only. So that if I divide this with this, pi into 10 to the power of 7 seconds, this will be closest to 200 seconds per year. This is so 200 years. So which is very tough. So that 1 coulomb is very large charge. That's why we are using in micro and nano and picocoulombs. So this is about charge and its properties and electrification. I hope you understood every concept clearly. Just please subscribe my channel Progressive Physics Learning Profile. Have a great time.